Hi everyone, I'm Christina and welcome to the fourth video in our A-Level Mathematics Calculus series. In this video, we're continuing to look at differentiation from first principles. So this is part 2. And the objective for this video is to work out the derivative of a function from first principles. So we're going to apply our definition of a derivative to an example function. So in this example, example 1, we want to work out the derivative of 3x squared from first principles. So let's first recognize that our function f of x is equal to 3x squared. And we want to find f dash of x. So from our last video, let's recall our definition of the derivative f dash of x. So it's the limit as h tends to 0 for f of x plus h minus f of x all over h. So let's work out f of x plus h. So all we're doing here is substituting x plus h into our function of f of x. So we're going to get 3 bracket x plus h squared. And so from here, we'll expand the brackets. If we write it first as a double bracket, it'll be easier to see how we're expanding here. So we're going to apply the FOIL method for expansion. So we'll take the first term of the first bracket and multiply it with the first term of the second bracket. And then with that same first term, we'll multiply it with the second term of the second bracket. And then we move on to the second term of the first bracket, multiply it by the first term of the second bracket. And then we multiply it by the second term of the second bracket. So what will that give us? We'll have 3 brackets x squared plus x times h is xh plus h times x is hx, which is equivalent to xh, plus h times h, which is h squared. So we can simplify a little bit because we can see xh plus xh gives us 2xh. So we can write it as 3 bracket x squared plus 2xh plus h squared. And we can also just multiply each term through by 3. So that will give us 3x squared plus 3 times 2xh, that's 6xh, plus 3 times h squared, that's 3h squared. So now let's take these functions and apply it to our definition here. So f dash of x is equal to f of x plus h, but we just worked that out. It's going to be this here. So it's 3x squared plus 6xh plus 3h squared minus, so just to make sure we understand, I'm putting that first expression, f of x plus h, in brackets because we're taking that and then from there we're taking away f of x. So we're doing minus f of x, which is 3x squared all over h. And we can label it here just to make it very clear. All of this here is our f of x plus h, and this is our f of x. So it matches our definition of the derivative. So the last thing, limit of h tending to 0, let's try and simplify the algebraic fraction we have here. So that's going to give us f dash of x, the limit of h tending to 0. So we can see here that we have a 3x squared minus 3x squared. So our 3x squared term will disappear. And what we're left with is just 6xh plus 3h squared in our numerator. So 6xh plus 3h squared over h. So the h remains there. And we can see that we have an h in each term in the numerator. So we could factor out that h. So we're adding brackets back in here. We're taking the h out from each term. So inside the brackets, we have 6x plus 3h all over h. And from here, we can see that h cancels in the numerator and the denominator. So then we have limit of h tending to 0 for 6x plus 3h. But of course, now, as h goes to 0, this term here, 3h, will be 0. So we can just write that our derivative f dash of x is equal to 6x. And so from first principles, we've shown that for the function of 3x squared, the derivative of that function from first principles is 6x. So in the next video, we're going to go through another example together.